This is part of the subject given in 2019, and here in this video will we address the A requirement. For that I have written a program which contains the given code, but I added a printf which will output the current iteration, the process identifier of the current process, and the PID of its parent. I saved the C program, I compiled it, and I executed it. Before we will start to draw the diagram, we will take a look at the output of our program. But before that, I have executed here the ps command, which gives us the PID of the bash, 1463317. And here in the output of our program, we have for the 0 iteration the selected line, which is actually the first process, because you see here for the 0 iteration we have as the PID of the parent the PID of the bash. It means that the first process, the process which was created by executing our executable file, will have this PID 1505294. We will name all the processes thereafter with the last 3 digits. So let's say that our parent has the PID 294. Do you know by any chance why do we have this line here and not before? If you do, just pause the video and write it into the comments. The reason is this wait, because the parent process will be blocked here with the wait until the child is finished, but during those iterations that child will create other children, and those children will create other children as well. So all of those have to end before we can get to this printf in the first process, 294. That's why we have this line here in the middle. So let us draw the diagram. First of all, we will take the code within the for cycle, line 4 and 5. Here the system called fork will create a new process, and it will return within the newly created process the 0. So that condition will be true only for the child process, but here in the brackets nothing will be executed. So both the current parent process and the current child process will go on to the wait system call as well, and to the further iteration of the for cycle. And we will unpack the for cycle by writing 3 sequential steps. Namely, for I equals 0, for I equal 1, and for I equal 2. And we will copy the code for each of those steps. Further on, we will draw the bash process, which creates the first process with the PID 294. At the first iteration, when I equals 0, that process, because of the system called fork, will create a new process, and that is 295. And that process will go on the next iteration for I equal 1, and it will create a new process, 296. And that process will go further on to the next iteration where I equals 2, and it will create the process with the PID 297. Only after all the children are finished, the printf will be executed. You can follow up the steps on the output. And when the child of the process 296 is finished, then the process 295 can go to its next iteration, meaning the iteration with I equal 2, and it will create a new process, namely 298. Further on, because that process ended, then the process 294 can go to its next iteration for I equal 1, where it will create a new process 299. This process will go to the next iteration and it will create a process 300, after which those processes end and process 294 can go to the last iteration for I equal 2 and create 301. I do have now another question for you. Do you know by any chance why our program prints the first line as the first line for our process 295 on the iteration 0? You can pause again the video and write in the comments if you know why. The reason is again the weight, because in the first iteration where I equals 0, for the process 294, weight forces this process to wait the ending of the process that it created in this iteration, namely 295. So up to the point that the process 295 ends, the process 294 is blocked on that wait system call. But in this iteration, the process 295, it's a child process, so it has no other processes, it's not a parent, so for it the system call wait will return an error, so it will do nothing, it will return on -1. And afterwards, for the process 295 in the iteration with I equals 0, the code will go on and printf will follow. And that's why we have the printf for the process 295 for iteration I equals 0 as the first line in the output of our program. You can also have a simpler diagram, only the diagram of relationships between the processes that are created. So now we are writing the iteration of the cycle for I equal 0, I equal 1, and I equal 2. And we will start with the first process 294, which is created by launching our executable, which creates at the first iteration process 295, which creates at the second iteration 296, which creates in the last iteration 297. And again 295 creates at the last iteration the process 298. Then the first process creates at the second iteration 299, which creates at the last iteration the process 300, and again the initial process will create at the last iteration the process 301. This concludes my explanation. Hope this was helpful and you can understand what I wanted to explain to you. If there are things that are still unclear, please let me know. And for other exercises you want me to clarify, please again let me know. Maybe it's better to use the comments as a way of communicating, because in that manner everyone can see the communication and everything is transparent. I wish you the best of luck. Bye.